Hey, geometry students, welcome to an easier lesson on distinguishing types of parallelograms. Now, in a previous lesson, we just went over some properties of parallelograms, and this is really a properties of parallelograms lesson as well, but we're going to be talking about special parallelograms. So we're going to be specifically talking about rectangles and rhombuses, and then also indirectly squares, because remember, squares are just rectangles that are also rhombuses. Now, just to remind you, a rectangle is a parallelogram. So it has two sets of opposite parallel sides, but it also has right angles, only right angles. Okay, so you can picture what a rectangle looks like. A rhombus is a parallelogram that has four congruent sides. Now, this is a rectangle. This is a rhombus. Notice that a rhombus can be slanted and still have four congruent sides. A square is a rectangular rhombus when we put those two characteristics together. All right, now let's take a look at these. If a parallelogram is a right, if an angle in a parallelogram is a right angle, just one, you just need one angle in a parallelogram. If you know your figure is a parallelogram, if it has one right angle, all of the angles are right angles, and therefore it is a rectangle. If you can just prove that there's one right angle, that is a property of a parallelogram. Another property of a parallelogram, if you know that two consecutive sides in a parallelogram are congruent, that means the other two sides of a parallelogram have to be congruent. So that means if you know that two sides, two consecutive sides are congruent, it has to be a rhombus of some kind. It could either be a rhombus like this or a square. And then lastly, if a diagonal in a parallelogram bisects opposite angles, okay, what does it mean to bisect an opposite angle? That means that it cuts opposite angles perfectly into two congruent angles. If it bisects opposite angles, then it is a rhombus. All right, those are the three properties. Now let's see how we can use those properties to work problems. So we're going to have a bunch of questions that ask us, is this parallelogram a blah? And we have to answer that question. The way that we're going to do that is by doing math with the things in the parallelogram to see if it is what it asks. So first of all, is this parallelogram a rectangle? Well, okay, first of all, we're assuming because it asks us, is this parallelogram? The assumption is that it is, in fact, a parallelogram at least. Let's see if it's a rectangle. So if it's a parallelogram, that means that opposite angles are congruent by the properties of parallelograms. So I'm going to say 6x plus 12 has to equal 7x minus 1. Now, I can solve this for x, and if the value of x multiplies within these to make these angles 90 degrees, bam, I have a rectangle. So what I'm going to do is subtract 6x from both sides and add 1 to both sides. I'm going to get 13 equals x. That worked out. Minus 7x minus 6x is just x. 12 plus 1 is 13. All right, so let's see. 7 times 13. 7 times 13 is 91. Minus 1 is 90. I could also do this way. 6 times 13. 6 times 13 is what? 68? 68 plus 12. Or is that right? Let me just think about that for a second. 6 times 13. 6 times 10 is 60. 6 times 2 is 18. 60 plus 18 is 78. I was wrong. 78. Okay. Plus 12 is 90. Yes, this is a rectangle. So my answer here, I would say yes. The angles are 90 degrees. Okay, so we proved that that's a rectangle. Verify, bam, and let's go on to letter B. All right, letter B. Is this parallelogram over here a rhombus? All right, to figure out if it's a rhombus, we need to see if two consecutive sides, at least two consecutive sides, are equal. Well, I know it's a parallelogram, so not only do I know that opposite angles are congruent, I know opposite sides have to be congruent in a parallelogram. So I do know that I can set 4x plus 7 equal to 9x minus 5. And then I'm going to go ahead and subtract 4x from both sides and add 5 to both sides. That gives me 14 equals 5x. Let me just double check that. No, 12. 12 equals 5x, right? And let's just make sure again. So 4x plus 7 equals 9x minus 5. 12 equals 5x. And then if I divide both sides by 5, I get x equals 12 over 5. But in order for this to be a rhombus, this would have to be 81 over 5, not 12 over 5. So this answer is going to be no. I'm going to say no. Um, I'm sorry, consecutive sides are not congruent. And let's see if I'm right here. All right. Is this parallelogram here a rectangle? Ugh, it looks a little shady. I see that little pixelation on the side, which means it's probably a little diagonal. Let's find out. You know what? I took a break to go and check the mail, and someone had sent me 2 more properties of parallelograms. And I'm just like, you know what? Join the party, little fellas. One of the properties of a parallelogram is if the diagonals of a parallelogram are congruent, then we have a rectangle. So since AC here is congruent to BD, okay, this whole diagonal is congruent to this whole diagonal, we're dealing with a rectangle. Hey, that seems like it might be useful in the problem we're currently working. Let's find out. So for letter C, I see that one diagonal is 10. 5 plus 5 is 10. My other diagonal is going to be x minus 3 plus 1 half x plus 1. But wait a second. This is a parallelogram. This isn't any quadrilateral, okay? In a parallelogram, the diagonals always bisect each other. So, yes, this entire length is x minus 3 plus 1 half x plus 1, but this half of the diagonal has to equal this half of the diagonal because they're bisected in a parallelogram. So you have to know the properties of parallelograms to be able to work these, just in order to set up these little equations. All right, so what I'm going to do is I am going to subtract 1 half x from both sides and add 4 to both sides. That's going to give me 2.5 x over here because I'm sorry, what am I doing? Subtracting 1 half x. So 1 half x on this side equals, and then I'm adding 3 to both sides equals 4. And then I'm going to multiply. So it's going to be x equals 8. X equals 8. All right. Now, if x equals 8, that means that x minus 3 is 5. 1 half x plus 1 is 5 because 1 half of 8 is 4 plus 1 is 5. So this is going to be a rectangle because 5 plus 5 is 10. 5 plus 5 is 10. The parallelogram has congruent diagonals. Letter D. Is this parallelogram a rhombus? Well, I found this other property of parallelograms in the mail. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. Um, well, I would have to be able to prove that these two angles here equal 90 degrees. Now, I noticed that these two angles form a linear pair, okay? So this one's going to be a little bit of a different setup. If you say that those are equal to each other, technically, you're not proving anything. What you need to prove is that 4x plus 13 plus 6x minus 13 equals 180, and then that x results in an angle measure that's 90 degrees. And if x results in an angle measure that's 90 degrees. So you see what I did? I added this angle to this angle, and because it's a linear pair, it's going to equal 180. Let's find x. So 4x plus 6x is 10x. 13 minus 13, oh, that is going to go away, equals 180. That means that x equals, when I divide both sides by 10, 18. All right, 4 times 18. Let's see, 4 times 10 is 40. 4 times 8 is 32. So that's 72 plus 13 is 72. Wait a second, 72 plus 13? That's only 85. And then let's see. Let's make sure that I did that right. This one should equal 95 because they have to add to 180. if I did this right. So 6 times 18, let's see, 6 times 10 is 60, 6 times 8 is 48. So 6 times 18 is 108, minus 13 is 95. Yeah, so these are not equal to each other. They do, or, I'm sorry, well, they're not equal to each other, but they also don't make 90-degree angles. So this is not a rhombus. No. Um, the let's see, what do we even say? The diagonals are not perpendicular. All right, let's see if we're right here. Here it is. Is this parallelogram a rhombus? All right, well, I have a feeling that this is going to have to do with our last property of parallelograms that we haven't used yet up here. If a diagonal in a parallelogram bisects opposite angles, then it is a rhombus. Okay, so we have to check and see whether this is equal to this and this is equal to this. But this one's a little hard because what I need is some statement about parallelograms that's true in order to work this. I need to figure out something that I can, because I can't just set 2x plus 11 equal to 3x plus 4. Because I don't know that they're equal yet. I have to prove that they're equal or not equal. Well, here's one thing I can do. This is a parallelogram, so I know that opposite angles are congruent. So that means if I add up 2x plus 11 plus 3x plus 4, that has to equal 5x minus 10 plus 4x minus 3. This plus this has to equal this plus this because this angle has to equal this angle. All right, let's simplify by combining like terms. 5x plus 15 equals 9x minus 13. Now I'm going to subtract 5x from both sides and add 13 to both sides. It gives me 28 equals, and I was going to subtract 5x, so that gives me 4x. X equals 7. So x has to equal 7 using the actual properties of parallelograms. Now let's see if these angles are congruent. 2 times 7 is 14, plus 11 is a 25-degree angle there. 3 times 7 is 21, plus 4 is a 25-degree angle there. These would have to be the same. 5 times 7 is 35, minus 10, 25 degrees, and then 28 minus 3, 25 degrees. The answer is yes. Opposite angles are bisected by the diagonal. All right, lastly, letter F. We're going to be using what we learned here. A sign in the shape of a parallelogram has diagonals that create equilateral triangle as shown. Is the sign a perfect rectangle? Explain how you know. Well, okay, which one of these might I use to prove that it's a perfect rectangle? I would probably use this property where I have diagonals that are congruent. If I have congruent diagonals, I see the diagonals drawn here. Now I know that this is an equilateral triangle, okay? That means that this angle here has to be the same as this angle here, which is 60 degrees, 60, 60. And because it's a parallelogram, I know that this opposite side has to be equal to this side. This side is parallel to this, so this angle is congruent to this angle, which means that this angle has to also be the same as this interior angle to make a parallelogram, because these are congruent angles on opposite sides here. So this also has to be a 60-degree angle. This has to be a 60-degree angle. Guys, we're dealing with two equilateral triangles that are congruent to each other by side congruence. That means that this side and this side are the same. This side and this side are the same. The diagonals are congruent. So yes, we have a perfect rectangle. And that's how we know we can prove that these are both equilateral triangles and the diagonals are congruent. So by the properties of parallelograms, we know that yes, this is a perfect rectangle. All right, you are ready to do numbers 1 through 30 for next time.